Hi, student. Okay, good morning to everyone. Okay, just want to same thing lah. I want to ask the student that you can see me and also you can listen me or not. Okay, okay, Yiru, can you see me and also you can listen me or not? Okay, morning, Shabrina, morning, Siti. Okay, can see me or not? Okay, wait some student to come in, Can, Okay. So today I want to discuss the two exercise. I already upload there. So for the student not in my class, you can go to description there. I already is put the link, so you can download from there. Okay, for my student 5 science 2, you can go to Telegram to download lah. I already upload that. Okay, this one is one of the exercise before that I give you. So hopefully you are finished. So today I want to discuss all. Okay, you also can be mark it lah if you got paper. Okay, so from here I can start my lesson lah. So I want to close about the liquid pressure. So I discuss all the exercise, then we go through another topics. Okay, then we go through the next one. Okay, this one's a formative practice. It's from the textbook. So 2.1, hopefully you are finished. You do inside your exercise book. So today I want to discuss the answer. Okay, now you can give me the answer like because you finished already, is it? So from here, you need to state the three factor that affected for the pressure in the liquid. Okay, what is the three factor that will affected the pressure in the liquid? Okay, remember the formula for a liquid pressure. P equal rho Hg. So that means the rho Hg should be the three factor that will affected the liquid pressure. So from here, anybody can type for me to show me you understand the factor affected the pressure of the liquid. Okay, so you just type in the chat room, then we can see your answer. Okay, so just make sure you know the formula actually inside the H, the rho, the G actually is what. Okay, I want the name, I don't want the symbol. So from here, I just wait the student give me the answer for the rho Hg. Actually, what is that? Okay, anybody can be typed here. Then we can pin your answer. Okay, with some student. Okay, today just let student only. Okay, we got Siti, Yuru, Linghan, and the Sabrina only. Okay, where the rest to go? Okay, anybody can answer me? The three factor. Okay, the three factors. Okay, depth of liquid, density of liquid, gravitational acceleration. Okay, that's the answer. Perfect answer from Yuru. Okay, we're going to check. Okay, depth, density of liquid, and also the gravitational acceleration. So that one is a three factor that will affect for the liquid pressure. Okay, so Nixon also correct. Okay, then we go to the next question. Okay, what is the water pressure at the depth of 24 meter in a lab? Okay, then the depth of the water density they give you that's 1,000. Then the gravitational they're using 9.81. So they want to find the water pressure. So this one just simple lah. We apply all the things that mean we can get the answer. Is it? So I want to get your answer. Okay, I want to find the liquid pressure. So important, all the info we need to know first. Then we create the equation. Water pressure, the formula should be the H rho G. Okay, so we apply all the things. The H is a meter, then we no need to change. Then we just put 24. Okay, the rho should be 1,000. Okay, after the G is 9.81. Okay, so Yiru give me the answer is 235,440 Pascal. Okay, so we're going to pin the answer. So we're going to check. Yeah. Okay, you can give me the standard form also can. You want to give me the whole number also can. That's the correct one. or you want to change become kilopascal, also correct. So if you change kilopascal, then should be 235.44 kilopascal. Okay, if you're using standard form, also can. If you want to convert to standard form better, we got 2 decimal point behind. Okay, that one we call standard form. Okay, so the student correct. Then we continue to the next question. Okay, the next one should be the number 3. A diver that dive to the depth. There's a 35 meter in the sea. Okay, what is the actual pressure? Okay, the key word is the actual pressure acting on his body. So from here, they give you is a density. Okay, they give you density. So from here, density we know already. Gravitational sure 9.81. Atmospheric. So they give you atmospheric means that ask about actual pressure. That means later you need to add your atmospheric pressure. So from here, we go to show the formula first. Okay, Jaya give me answer already. Okay, the water pressure 35 multiply 1060 9.81. So we go to find the normal pressure first. Okay, this one is water pressure. Okay, if I want to using kilo, then I just go to the inwards, or you straightforward you can take 363.951 kilopascal also can. Okay, if I round number, I take 364 kilopascal. So I need to plus about my answer for the atmospheric pressure, is it? So I need to add. So actual one, I need to add another kilopascal. So from here, the answer is a 464 kilopascal. Or you can write the full one, 463.951 kilopascal also, okay? Just like the answer from the Jaya. Okay, Jaya give me the full answer already. That's a 4,063 463,951 Pascal. Okay, so this one should be the answer for the formative 2.1. I think there's a no problem lah for the student. Okay, so we need to continue to the next one. Okay, this one, you can go there. Okay, from there, they got description, is it? Okay, from the YouTube. So below, they got the exercise link. So the first one should be just now that one. Sorry, not just now. It's the yesterday I show you one. Okay, another one is today one. So both I also upload in your Telegram. For the student not in my class, that means you can click here. Okay, you can click here. After that, you can go to download. Okay, so we straightforward to continue the first one. The first one exercise today we need to discuss. Okay, so the first one that should be here. Okay, this one. Okay, you also can be scanned. I got show here. You can scan about the link. Okay, so from here we can go and see the figure 1. Okay, we show the figure 1 first. Excuse me. So this one is a figure 1 for the cross section of the pond. There's a 5 fishes, V, W, X, Y, and also the Z. Okay, the density of the water in the pond is 1,000 kilogram per meter cube. Okay, they give you density of water. Atmospheric pressure also provided. There's 100 kilopascal. Gravitational, okay, they want to using is a 10. They want to using the gravitational acceleration is a 10. Okay, now what they want? Let's see the first question. Okay, can you state the pressure? Okay, that's experienced by the fish V. Okay, they want V only. This one is a fish V. Okay, actually what pressure acting on the fish V? Okay, we just got surface pressure only. So the surface pressure, there should be the atmospheric pressure, is it? So from here, what is the atmospheric answer? So we straightforward copy from the question. So you just state the pressure experienced by the fish V, there's the atmospheric pressure. So you go to list out. Atmospheric pressure is how many? There's a 100 kilopascal. That's all. This one is the answer for A. Okay, they ask about the V. So you mention first, V is what name? After that, you give the answer for atmospheric pressure is how many. Okay, number 2. Okay, number 2, they want to calculate the actual pressure acting on the fish Z. Okay, So from here, you need to find out what is the water pressure acting to the Z. Later, you need to plus together with the gravitation, the acceleration, the atmospheric acceleration. Okay, sorry, atmospheric pressure. So from here, we need to add both of the pressure, then that one become actual pressure. Okay, so from here, the student, you need to do the calculation for me lah. You calculate the what's the reading for the water first. After that, you go to plus about atmospheric pressure. Okay, so from here, I didn't show anything. So I hopefully you can do the calculation. Then you straightforward to show me the answer. Okay, let's see. Got student to answer me or not? Okay, overall, we need to find out the overall. Okay, so we go to weight. Okay, find one by one. You find the water pressure first. Because water pressure, we got 3.6. That's a meter, is it? The question was shown. Normally we using meter lah. They never show anything. So 3.6 meter. So after that, they told you there's a density 1,000. Okay, after that, the gravitational, there's a 10. Okay, then after that, you go to plus atmospheric pressure. Okay, I think they miss out about the meter. 3.6 should be meter, not cm. Cm so small only. Okay, so this one should be the meter. Okay, anybody? Okay, anybody can give me the actual answer? The pressure acting on the fish Z. Okay. Okay, Sabrina, they give me 136 kilopascal. Okay, we go to check. Is it 136 kilopascal? Okay, first one, we find the depth of the fish Z. That is a 3.6 meter. Okay, then Yiru also give me the same thing. Okay, 360,000 pascal. Plus about the 136 kilopascal. Okay, we go to check. So this one is the info. Okay, we get the info first. Then we continue to the next one. Pressure at the fish Z, that's equal to the rho Hg plus atmospheric. Okay, then after that we continue. Okay, so H rho G means 3.6 multiply with the 1,000 multiply with the 10. Then later you need to plus your 100 kilopascal. Okay, then after that we get it 136 kilopascal. Okay, so you can write in the full also can 136, after that got 30 behind. So this one is a full calculation from zero. Okay, water pressure plus about atmospheric. So the answer should be 136, then 30 behind become pascal. Okay, okay, then we go to the next question. Okay, same question again. Now we go to C. Okay, which one fish will experience the same pressure as a Z? Okay, which one is same with the Z? Okay, you see the diagram you find for me. Which one fish? They got same liquid pressure or atmospheric pressure with the fish Z. Any answer? Same as the fish Z. That means the pressure just now you find 136 kilopascal, is it? Or the Z. So that means another one also same. There's a 136 kilopascal. Okay, we go and find which one the fish will get the same thing. Okay, fish X. Okay, so fish X, now you need to give the reason. Okay, why we know there's a fish X? We got so many, is it? You got V, W, we got Y. Why you want to choose about the X? Okay, so Sabrina, why you want to choose X? So you need to answer it. Okay, Ling Han also say X. Why? What's your all reason? Why you say there's a X? Okay, so I want to check, is it your answer correct or not for the explanation? Okay, we are not only choose only, we got proof, is it? So you need to explain why you need to choose this answer. Okay, they are in the same depth. Almost the same depth. You can say same depth, same level. Okay, Lihan, that's correct. Okay, they are in the same depth. Yeah, correct. Okay, same depth as the Z. Yeah, okay. So you can say the fish Z and also the fish X, they're almost in the same depth. Okay, same depth means same level. Same level, that means they can get the same pressure. Okay, so we're going to see the explanation. Fish X, because fish X and also Z are at the same level of the depth. Okay, so everybody also correct. So from here we understand already, same level in the same liquid, sure you get the pressure should be the same. Okay, then we go through to the next one. Okay, question number 2. They show about the YouTube. Okay, fill with the two type of the immiscible liquid. Okay, we do know what's liquid. One is labeled X lah, another should be labeled as a Y. Okay, the question they give you density for the X, 920. Okay, compare the density of the X and also the Y. Okay, they help me to compare. Which one denser, X and also Y? Okay, which one density is higher? Okay, you see the diagram, then you know already. Okay, which one denser, which one is a less dense? Okay, anybody can try. Okay, you see the YouTube, you see the different level, then you understood already which one should be denser, which one is a less dense. Okay, we're gonna wait the student. Okay, maybe here slow a bit. Okay, because YouTube and here maybe the link, the line got slow a bit. So the student, you type the answer, I still not yet can be see it. Okay, I still want to wait a while. Okay, that means when I just ask, you also can be exactly to listen, is it? So you also need to wait a while. So from here, we're going to wait the student lah. How about the density for the X and also the Y? You just do the comparison. Okay, comparison about the liquid X and also the liquid Y. Okay, the student, can you answer me? Okay, Y is denser than the X. Okay, so this one should be correct. Y memang is denser than the X. Why? Because you see the X above, is it? The Y is below, is it? Okay, this one should be the denser. Y is denser, X is a less, but you need to explain. You need to explain. So you refer the diagram, you go to explain lah. Because the liquid Y at the bottom, is it? They can support the liquid X until the liquid X can go above. So that's why we say the Y become denser. Okay, so the Sabrina answer should be correct. Then after that, the question got add one more. They need to explain your answer. Okay, so we're going to see the explanation. Okay, the explanation is the density for the Y memang is bigger than the X. Okay, the reason is a shorter column of the liquid Y can be support. You see, this one is the same level, is it? Okay, we just using 9.6 cm up only. After that, I can support the liquid X until 12 cm. So that means I using the shorter column of the liquid Y, I can be support the higher column of the liquid X. So from here you can do the comparison. So that's why I call you draw the line when the two liquid difference. Okay, we draw one straight line. So that means we different two liquid. So finally we can see the liquid Y just using 9.6 cm go to support 12 cm of the liquid X. So this one is the reason why we need to draw the line. So we can see very clear. Okay, two different of the liquid, what's the difference? Okay, then we continue to the next one. Can you calculate the density for the Y? Calculate the density for the Y. So for the YouTube, actually the function is almost like this lah. They always call you to find the density for another liquid. So from here, important you need to know, these two situations we just ignore atmospheric pressure because both also open. Both also open, so that means the atmospheric pressure we just ignore. Then same level, same pressure. So that means the pressure A same like the pressure B. Okay, so we're using the formula for the liquid pressure, rho Hg. So another thing we also can be cancelled, there's a G. Because both sides the gravitational acceleration is the same. So from here we just put rho H. Okay, for the A equal rho H for the B. Okay, so the student you find for me was the liquid density for the Y. Okay, for the Y, the density is how many? Okay, so you prepare your calculator already. You just stand by. After that, you straightforward to press it. After that, you can type. Okay, remember the unit for density is how many? Yeah. Okay, we follow the question. There's a kilogram per meter cube. So later you type your answer. You must read unit. Okay, so from here we get the answer from the rule 1150 kilogram per unit cube. Okay, Sabrina also the same. So we go to chat. Okay, Lingha also the same. Okay, so from here we write the info. H1 is 12 cm. Then this one should be 9.6. Row 1 is a 920. Then the pressure point A equal pressure point B. Okay, then we continue. Row 1 H1 equal row 2 H2. Then apply. Row 1 should be 12. 920 multiply with G. Say G we just cancel later. 9.6 multiply with the row 2. Actually, both also CM we cancel each other. Okay, no need to put, no need to change. Okay, the last one, you go and find what is the row 2. So the row 2 is a 1150 kilogram per meter cube. Okay, exactly is the answer. Okay, thank you for the three students. Today the lesson only three students. There's just Iru, Sabrina, and Ling Han. Okay, the others I don't know. You got see, you got watching, or you just silent only. Okay, so hopefully you also can type lah. Don't be lazy because I know you don't want to talk. Okay, although got mic, you also don't want to talk. You also don't want to on your cam. So from here you just go to type. Okay, then we continue to the next one. Okay, figure 3. They show about the ball bearing, the image in the water. Can you state the three different way how to increase the water pressure on the ball bearing? Okay, now the level for the ball is here. I want to increase the water pressure acting on the ball. So you need to mention the three different way. Okay, three different way how to make the pressure acting on the ball will be increasing. Okay, any idea? From here you can type already. Okay, what's your idea can make the water pressure should be higher? Okay, they're acting on the ball bearing. So you just think about the formula lah, the rho Hg. G we cannot changes already because you do the experiment that's in the earth, is it? So we just change about the H and also the rho. Okay, how you go to change the H? Okay, okay, how you make the H become bigger? Okay, so that's why the pressure become higher, is it? So from here, any idea? Increase the depth of the water. Okay, so Yiru say increase the depth of the water. Okay, Jessica say add water. Yeah, correct. So when you add the water, so that means the depth will be increasing, like, is it? So another one, Sabrina say, submerge, immerse the ball bearing to the bottom of the bottle. Also okay, that's the same. Okay, so that means if I don't want to move the ball, I add water lor. Okay, if I want to add the water, I just make the ball bearing go downwards. Okay, I make it go downwards. So that means later I find it the depth will be increasing. Okay, this one is a good idea. So we go to show first. Okay, first one you say lower the ball bearing. Okay, so after that greater depth. Okay, number 2, we can say you add the water. Okay, add the water in the bottle. Last one, increase the density of water. Yes, how to increase, Ling Han? Okay, you can increase the density of the water. Okay, how to increase the density of water? Okay, any idea? Make the water more denser. How? How to change it the density of the water? Okay, use the green saline instead of water. That means you change the whole liquid already. Okay, is when you say change become Rizaline means you change the whole water already. So that means that it's the changes the liquid, changes the denser liquid. That one is the changes the denser liquid. Yeah, Sabrina is correct. They say add the salt in the water. Add the salt in water means you totally change about density of water, but you never replace another liquid. So that's the correct. So the simple thing, we just go to add, okay, dissolve some of the salt into the water. So when you just dissolve the some of the salt you put inside the water, so the density should be changes. Okay, they become increases. When the density just increase, that means the water pressure, the automatic will be increases. Okay, add denser liquid into the water. What means add denser liquid to the water? If you add denser liquid into the water, that means you got two layer already. Okay, two layer, we cannot find out the density, which one you want to use. Okay, Linghan, don't add another denser liquid. We just can add something to dissolve together with the liquid. After that, you change the new liquid. That one, we call it, we add the salt. So they become salt solution. Salt solution, that means the density become higher. Okay, don't add the two different liquid. After that, they will separate. Okay, so now we go to next one. Okay, then we continue to this question. Sorry, my answer come already. Okay, this one. They call you to draw, is it? Okay, so from here you need to sketch the graph of the water pressure on the top surface of the block against the depth. So this one is a depth. Okay, so that means from here we know already when the depth just increase, that means you make the block go down more, you find it the pressure higher, is it? So from here the graph should be directly proportional lah. So from here the pressure will be keep increasing when the H increasing. So that means the head just can go until the certain level, until the bottom, so no more already. So the pressure already is a fix. So from here, starting from the surface until before you touch to the bottom, so they're still directly proportional. Okay, pressure keep increasing with the H. Okay, so the just now that part already finished. So this part should be another link one. Okay, so from here, I'll show the link first. Okay, this one should be the link for this question. Okay, student, you can get from just now the link. You also can be scanned here. Okay, let's see the question first. 5.1, they show the water in the container. Okay, the water they pour out from the hole of the point A. Okay, due to the pressure of the liquid. Another one also same, but the water, now the point should at the bottom. Okay, same container also. Now the water they spill out from the hole at the point B. Okay, the first question, they ask you what's the meaning first. They never ask about comparison first. So they ask you what means by pressure. Okay, pressure, we're still using the normal formula. The pressure is a P equal F over A. Okay, liquid pressure, we don't have any definition. We still follow the original pressure. So the pressure should be perpendicular force. That means the F over A. Perpendicular force that acting on a unit of surface area. So that one is a definition for the pressure. Okay, so we don't have any definition for the liquid pressure. Rho Hg, no. Okay, you don't mention the equation also. Important, you need to explain F over A using the sentences, to using the symbol. Okay, that one is a definition for the pressure. Okay, now we're going to see the diagram. Okay, we're going to guess lah. Later the question sure there's a comparison because we got two diagrams, is it? First one, we're going to find what's the difference. Okay, the position for the A and B is a different. A is higher a bit, B is lower a bit, is it? So the pressure should be is higher because increase with the depth of water. Okay, now you see the water that spill out. Okay, we find the B is further. Then they spill out further distance, is it? So from here we know the conclusion is when the depth increase, pressure increase. Pressure increase when the water want to spill out, they must go further. So from here we find it P is further than the R. Okay, so this one is what we understand about the diagram. Okay, question we still don't know. Okay, we see what they want to ask. If you understand the diagram more, that means later they ask the question, you easy to be answered it. Okay, so from here we understand the diagram already, then we can go through the question. Okay, let's see the question. Based on the 5.1, 5.2, compare the depth of the water. Okay, just now we do the analyzing already, is it? Depth of the water, point A and point B. So you straightforward. Depth of the water, point A less than B. Okay, or you want to say about the B. B is deeper compared to the A. Also can. So we just write, okay, depth at the point B is more than point A. Okay, so better you write more than, don't using the symbol. Okay, we're using the sentences. Okay, second one is compare the horizontal distance R and also the P. Okay, so we compare the horizontal distance. So we find it which one is further. So from here we can see the P is further, like is it? So from here we can answer the horizontal distance P is further compared to the R. Okay, so we can answer it. Horizontal distance P is more than the R. Okay, we go to next one. There's still a relationship already. They want to relate the horizontal distance to the depth. Okay, how you answer this question? Relate. Just now we do two comparison, is it? Depth and also the horizontal distance. So from here, excuse me, you need to explain. Okay, you need to relate it horizontal and also the depth. So which one normally we go to mention first? We go to mention is a manipulate variable. So from here, the manipulate variable is a depth lah, because we control the depth, is it? So we mention the depth first, then after that, just me, we explain about the horizontal distance. Okay, so from here you need to say when the depth increase. Okay, what happened for horizontal distance? The horizontal distance per out from the hole should be further. Okay, should be further. So from here we go to answer like this. As the depth of water increases, horizontal distance further. Okay, we just copy from the question. They said depth and water, depth, water, and also horizontal distance. So we just take the two physical quantity, put in the sentence, then you add increase or decrease like this only. So as the depth of water increase, so that means the horizontal distance become further. Okay, so this one we call relationship. Okay, then we continue to the another relationship. Can relate the depth of the water to the pressure of the water. So from here, depth still manipulate variable, pressure is a responding. So we still answer the depth first. When the depth increase, pressure also increase. Okay, you also can write in directly proportional, but you need to write in full sentence. Okay, depth of the water is directly proportional with the pressure. Okay, you can write by using the terms. Okay, so from here, as the depth increase, water pressure also increase. So this one is a relationship. Okay, can you state another factor that will affect the pressure in the liquid? So this one is depend for yours lah, your answer. Okay, what is another factor that will affect the pressure in the liquid? So from here, we cannot mention about the depth already, like, is it? Because that is totally mentioned in the diagram. So from here, you need to mention another factor. They will affect the pressure in the liquid. Okay, we're going to see the student can answer or not. Okay, just now this one already got question. They asked about the factor, is it? So from here, now you give me one of the factor beside of the depth that will affected the liquid pressure. Okay, what is that? Okay, we can see the student can answer or not. What's another factor that affected the liquid pressure? Okay, Eric Chu. Okay, density. Yeah. Okay, another one, density. So density of the liquid, another one should be the gravitational acceleration. These all will be affected the liquid pressure. Okay, thank you. Your answer. Okay, so Alicia, you come already. Eric also here. Okay, so from here, this one should be the answer for C. Okay, then we go to the next one. Okay, question continue. Okay, diagram 5.3, they show about a submarine. Submarine that can be submerged and also float in the sea. Okay, now explain why the wall of the submarine is made of the stiff and also thick metal. Okay, the wall. Okay, the wall surrounded the submarine. They're made by the very stiff and also thick metal. Okay, they need to explain. So this one is an explain question. The process question in AC, 4 marks. So that means at least you got 4 points to support. Okay, to support the explanation. Okay, why you want to using the thick and also the stiff metal. So this one sure is related with the liquid pressure, because the submarine they want to go to deep sea, is it? When they go to deep sea, that means the pressure should be higher lah. So you must talking about when the depth increasing, pressure increase. Okay, when the pressure increase, that means the wall must be very strong. Okay, the wall of the submarine must be very strong, stiff, and also thick, because you want to withstand the higher pressure of the liquid. Okay, higher pressure of the liquid, that means they will produce the bigger forces to acting to the wall. So that means the wall from the submarine, they can withstand the high pressure and bigger forces. Okay, so this one is how to explain. Okay, let's see point by point. You can write in point form. You don't need to write by paragraph for the physics. Okay, so from here you can show about the first one. The higher the depth, okay, the higher the pressure. So this one is 1 mark already. So you mention the depth and also the pressure. Okay, after that, the stiff and also the thick metal used. Reason? To withstand the large water. Okay, for this one question, we just got 2 marks only, because they don't have anything to explain more. Okay, if they ask you why they can float, why they can up, that one we got 4 marks. But this one, they just ask about why they're using the stiff and also thick metal. So we just got 2 marks. Depend the question. We got 4 marks, they mean to explain more. But this one is 2 marks only. So we just using the short sentence. So from here, the stiff and also the thick metal they use to withstand the larger water pressure acting on the submarine. Okay, if more mark, that means you need to add some more. There's a force. Okay, the force acting for the submarine also will be increasing. So you also need to withstand the higher forces. Okay, so from here, keyword higher depth, higher pressure. Second marks is about the to withstand the larger pressure. Okay, so this one is why the wall is built by the stiff and also thick metal. Okay, then we go to the next part. Okay, so question number 6. Okay, 11.1, they show about the patient being fed with the medicine from the intravenous injection for bottle. So from here, the medicine from the 4 bottle, that's able to enter the patient's veins due to the difference of the pressure. Okay, they put above 1.2 meter, so they want to create the difference of the pressure, then the liquid can be go in the body. Okay, now we're going to see it. Can you state the one of the factor that will affect the pressure in the liquid? So refer here. You can see the diagram. What's the factor that can affect the pressure in the liquid? Okay, so from here, if we refer the diagram, there should be the different height, like, is it? So another method you also can say about the density. You can say about the gravitational. But this one, that question, they never say refer diagram. They just say state one factor that will affect the pressure in liquid. Okay, they never say the intravenous injection. If they say intravenous injection, that means you need to mention about the height. Okay, they're just common. Okay, the question A is a common. So we straightforward go to answer lah. Atmospheric pressure, the height, the density of the liquid, they also will be affected. So you can see if I using the intravenous, inside got atmospheric pressure, is it? So atmospheric pressure trapped inside the intravenous, they also will be affected. Number 2 is a height. Okay, the different height. patient and also the intravenous injection, the height, and also density of the liquid. If you're using the liquid, is a different. Maybe using the blood. So that means the factor for the liquid pressure that will disturb. Okay, so from here there's a sum of the factor affected the pressure liquid. Okay, explain how the medicine they flow from the four bottle into the patient veins. Okay, can you see 4 marks? 4 mark is at least is a 4 point line, is it? So from here, first one you must talking where you put. Okay, normally you put at the higher level from the patient. Okay, why you want to put higher level from the patient? Because you want to create the different of the height. Different of the height, that means you produce the bigger pressure to lower pressure. So that means because of the different pressure, so the liquid from the bottle, they will flow from the high to low pressure. After that, they will go in the patient veins. Okay, so the almost the 4 marks talking about the pressure, talking about the height, then finally got different pressure, then they start to flow. Okay, we go and see the 4 marks, how to get it. Okay, first one they say the medicine from the fourth bottle, the bottle there's a hung higher than the patient. So the first one they're talking about the height. Okay, maybe you just mentioned the higher about 1.2 meter if from this one diagram. Okay, important is higher from the patient. Okay, number two, why higher? Number two, the liquid pressure in the fourth bottle become higher than the patient weight. Okay, after we're talking about the higher, number two, we're talking about the pressure. Okay, the pressure sure is higher. When they put at the top already, the pressure become increasing because the H increase. Okay, number three, we're talking about the flowing. Okay, liquid will flow from the high pressure to the low pressure. Okay, this one is a normal common sense lah. Normally from the high pressure will flow to the low pressure. So finally what happened? The medicine will able to enter the patient veins due to the high pressure of the medicine. Okay, so this one is a 4 marks. How we get it? So we just explain from A until go to Z until go to the patient veins. That one is a process question. So this one is how we go to explain. Okay, at least you can create some of the height. Then you're talking about the pressure. Then you're talking about different pressure. And last one, go to the patient veins. So you can write in point form. For the physics, we don't have anything you need to write in paragraph. Okay, they still can write in point form, so the markers is more easier to see the point. Okay, 1, 2, 3, 4. That means we see very clear. Okay, then we go to the next one. Okay, question C. Okay, calculation. So prepare your calculator again. Diagram 1.2, they show about the process for the channeling water from the tank on a hill to the tank of the tall building. Okay, water density, there's 1,000. Okay, then the gravitational they're using, there's a 10. Okay, so now the first question. Calculate the water pressure at the R. Okay, what is the water pressure at the R? R is here. R is here. So you want to calculate the water pressure at the R, they need to find H. Okay, how to find the H? H is from the top to the bottom, not at the bottom go up. So from here, this one is the base of the R. So you need to find the line. Okay, one straight line here. Above sure got 5 already, but this one 35. I want to cut. Okay, cut how many? 35 must minus the 20, is it? Because the bottom one I don't want. So from here, can you count for me? How to get the water pressure at the R? Okay, so we give the chance for the student to answer this question. Okay, C1. Okay, what is the pressure at the R? Okay, any student can try. Okay, simple only. You just find the different H. Important is a H. Okay. The answer from Yuan Ru they give me is a 150 kilopascal. The others, You can get the same answer from Yan Ru. 150 kilopascal. Okay, we just get one answer only. The rest, where to go? Eric Chu, where to go? Okay, Sabrina. Only one student. Okay, if only one student, then we go to check lah. Is it the answer correct or not? Okay, they give me the 150 kilopascal. So we go to show. Okay, we show the formula first. Rho Hg. Okay, how to get the H? 35 plus 5. Okay, then you need to minus the 20. Multiply. Oh, sorry. I do the wrong thing because there's a 9.81, is it? Okay, the other student also show me already. Okay, 150 kilopascal. So that means I do the thing become wrong because I take 9.81. So I do some correction. Student, you wait me a while. I do some correction first. Okay, if this one wrong, that means later I also got wrong already because I take 9.81. Okay, so I show again. So that should be here. Okay, this one is what? Okay, why I never change? Okay, so I go save. Okay, we're going to check is it correct or not. I still never changes. Oh, I changed another one. Oh, sorry. So I go to recall back. Okay, if change everything also need to change. So this one become 150 kilo. This one also change, so I need to do my calculation. So now you help me to change the another one. This one is 0, 35, 40. So 400 kilopascal. Okay, so we can show already. Okay, again. Rho Hg, then 35 plus 5, then minus 20, become 150 kilopascal. So this one, water pressure at the S. Okay, where is the S? Okay, S is here. Okay, S is here. So from here, they ask you what is the pressure at the S. So you can straightforward to type for me. Okay, just now got answer already. All correct. Just now the question 150 kilo because I never change about the gravitational. So very careful. Because this one question suddenly they say tag. So we all must using the tag. If they're using 9.81, then they need to using the 9.81. Okay, so from here you can check the answer for S. What is the pressure at the S? Okay, we wait the student to answer me. For what water pressure at the S? Okay, just is it we using three of the number here or we just use 35 plus 5? Okay, if they ask about the S, actually we know there's a 20, but 20 above I also need to calculate, is it? So the question provided 35, so that means I can ignore the 20 lah. Okay, I can ignore the 20, I straightforward take 35. Okay, so from here we're going to wait the student answer. Okay, pressure at the S. Okay, what is the pressure at the S? Okay, got any student? We still got 10 minutes. Okay, Jessica, they give me 400 kilopascal. Okay, so almost the same lah. Okay, because we take 35 plus 5 only. Sabrina is 35 minus 20, multiply 10. Sabrina, you forget got 5. At the top, we still got 1.5. Okay, 5 meter. So you still need to add the 5. Okay, I understand, Sabrina. Okay, 35 minus 20, then you need to plus 5. Okay, so from here, that means we ignore the 20 lah. We just take 35 plus 5, then become 40. 40 multiply 1000 multiply the 10. So the answer is a 40 kilopascal. Okay, that's correct. Okay, Euro also correct. Okay. Oh, Sabrina, you tell me that just now. Yeah, correct. Okay, you tell me that just now that one is 35 plus 5 minus 20. So that's correct. So first one should be 150 kilopascal. The second one is a 400K. Okay, then we go to the AC. So this one we call AC question. AC question is normally is a 10 marks. We can see how to answer the AC question. Okay, this one is the hydroelectric dam. Okay, they want to generate the electricity. So that means they get the water from the dam. Okay, normally the dam that we build at the high location. High location, that means the water when it just flow out, there's a in high velocity. Okay, when they're in high velocity, that means they produce a high pressure. They go and turn the turbine, and the turbine can generate electricity. Okay, so from here you can see the retaining wall. So this one retaining wall, they want to withstand all the water in the dam. Okay, so this one is a retaining wall. Okay, after that we got water flow. Okay, retaining wall. This one is the dam. Okay, after that when the dam just open, that means all the liquid will flow out. Okay, so from here the question is the table below they show about the characteristic of the four dams. Okay, four dams are we got JKLM used to turn the turbine. Okay, for electricity generation. So from here you can see they give you four aspects. You need to modify. Okay, the height of the retaining wall. They ask you the height. You want high or you want low. If you put the low, you give the reason. If you put the high, you also give the reason. So that means from this one characteristic, we got 2 marks. If you choose the characteristic is correct, then 1 mark. Another one should be the correct explanation. Okay, another one is a type of the material for the wall. Okay, this one wall you want to build by what material? So we follow the table. The table just give you two only, either wood, either concrete. So from here you go to choose, then you give the reason also. Okay, the next one is the thickness of the wall at the bottom. Okay, they ask about the bottom. So bottom you want thin or you want thick. And the last one, the shape of the wall. Okay, the shape of the wall you want not curve and also one is a curve. Okay, so now we need to explain first one by one first, then later we go to choose. Okay, for this one question, you've got questions are more. I'm going to refer the question. You are assigned to study the characteristic of the safe depth. Okay, keyword safe. Okay, explain the suitability of the feeders and also determine the most suitable. Okay, you need to explain first, later determine the suitable one. Give the reason for your choice. Okay, after you choose, you need to give the reason why you want to choose. Okay, sorry. Then we go to this question is a 10 mark, is it? When you see the question is a 10 mark, what you need to do, you prepare the table form. Okay, what means of table form? Okay, we can see this one we call table form. Okay, when you prepare the table form, they're more easier to answer. If you write in paragraph, that means we need to find your point is very hard. Okay, if your handwriter is okay, never mind lah. Because some student the handwriting is very thorough one. So that means we cannot see the point. So if you write in table form, we easy to find your answer. Okay, remember this one not your BM, not your BI. We need to find the paragraph first and all. Finally, other these are no. We don't have any paragraph like this. We just write in table form. That'll be easier to get the answer and easy to explain. So the first round, we're going to see the wall. Okay, the retaining wall, the height must be, okay, you want high or low? Okay, anybody can give me suggestion? Okay, the height of the retaining wall, you want high or you want low? Okay, anybody? Okay, we just can choose high or low only. We cannot choose medium one because they already give you the chosen. So we choose from the table either high, either low. Okay, so from here the wall you want to build. Okay, normally you want high or you want low. Okay, so from here high. Okay, Iru give me high. Okay, the reason. Okay, you not just give only the high wall actually what's the reason? The high wall that means you can blocking the water overflow. Okay, important I want the water go in the dam, is it? So the retaining wall you put there high, that means you want to prevent the water overflow through the dam. Okay, that one is high enough. Okay, so from here I say retaining wall must be high. Okay, when you answer characteristic, don't just say high. Okay, we do know what you want. So you copy from the question. The retaining wall must high. Okay, reason. Let's see the reason. Increase the depth and water pressure. So if the retaining wall become higher, you can block more water, is it? If you can block more water, that means you can store more water lah. That one is a retaining wall. Okay, if higher a bit, that means the whole tank you can store more water inside there. If I make it become lower, that means the water over already lah, is it? Overflow already. So that means that's the reason I cannot store more water. So if I make it become higher, the depth will be increasing. Okay, more water can put in, then increase the depth and also increase the water pressure. Okay, number two about the material for the wall. Okay, material from the wall, we can choose either wood, either concrete. Okay, normally I think the student is no problem lah. From here, we sure we choose which one. Okay, you choose the wood or you choose the concrete. Okay, I think this one is okay, is it? Okay, you just choose only, you just write full sentence. Don't say wood, don't say concrete. Then you must say the material of the wall is what? Okay, okay, concrete. Okay, both students also say concrete. So we go to answer. Okay, retaining wall, the concrete retaining wall. Okay, reason we compare wood and concrete. Sure, the concrete becomes stronger, is it? So you can say stronger. Okay, you also can say hard. You also can say about the to withstand the high pressure. You also can say not easy to break. Okay, so this one is when something there's a strong, we explain like this. Okay, Shafika also correct. Concrete. Okay, so we answer strong. Okay, or you go and say about do not break easily. Okay, why I do want to use then the withstand high pressure, because later we still got characteristic we need to explain, because the explanation we cannot crash. Okay, we cannot crash. So we don't so fast to using the only one explanation. So if this one can using strong, then we using strong to explain. Then the later one to withstand high pressure, we use for the later. Okay, now the thicker wall at the bottom. Okay, wall at the bottom, lah, the depth increasing, is it? The depth increasing, pressure increase, is it? How about the thickness? The thickness of the wall must be, this one I answer. They sure become thick. Okay, the bottom part must be thick wall. Okay, so why thick wall? So that's why just now I told you, don't using the withstand high pressure, because I want to left for this part to explain. Okay, if you explain already later, I cannot say strong already, is it? So I need to explain thicker wall. The reason is, okay, I able to withstand the high water pressure when the depth increasing. Okay, so this one is a reason. The bottom one should be thicker. The upper part, it become thinner is okay because the pressure still less. Okay, at the bottom, the pressure increasing already. So that means the bottom must be made become thicker. Okay, then the last explanation. Okay, the shape of the wall. Okay, the wall shape. They ask you, you want curve or do you want curve? Okay, for this one, the answer must be curve. Okay, some students, they say, I do know I want curve or do want curve. Okay, never mind, you can, from the table, you go to choose first. Okay, you see this one low sure out already. We don't want to use already. Okay, this one also low, then we don't want to use. So we just left K and L only, is it? So K and L. Then I want to using concrete. I don't want to wall. So L. Then after that, I want thick. So the answer just only for curve. Okay, no curve cannot use already. So you sure we know this one. Sure, the last one is the remaining wall must be curve. Okay, now we need to explain why you want to curve shape. Okay, curve shape means when the water just come. Okay, when the water just come, the some water will reflect back. Okay, some will go in, some will reflect back. So when it just reflected back, we got curve. The reflected can be reduced the pressure, can be reduced the pressure to come. Okay, when it just go back. So from here, we also can say about can reduce the refracted water pressure. Okay, the water pressure is come already, go into the dam, they want to come out, is it? Some cannot come out, they're blocking, they're reflected back, is it? Reflected back, when you curve, you find it, the wave that reflected back, they become less. Okay, if you flat, you find it when it just come very strong, go back also strong. Okay, so from here, this one is why we want to design by the curved surface, the curved surface of the retaining wall. Okay, you also can say about withstand the higher pressure because just now we mentioned already, so I don't want to repeat the explanation. So I using that can reduce the refracted water pressure. Okay, so we finish for the explanation. Now we need to go to choose. Okay, we go to choose one by one first. Not related, we go to cross. Okay, first part, low I don't want, then I go to cross first. Okay, second one, this is a wood. Wood I don't want, I also go to cross. Okay, bottom part I want thick. Then the thin is not related, I go to cross. Okay, last one I want curve one, the not curve one I go to cross. So finally, very clear. You can see the L. L is nothing. All is perfect what I want. So I go to choose should be the L. Okay, so now the explanation I just get 8 marks. Okay, if you all correct, there's 8 marks. Okay, last 2 marks we need to choose. So that means you need to mention L is chosen. When you just say L is chosen, 1 mark. Then please repeated all the characteristic just now you choose. Okay, so from here L is chosen. Okay, because they have the tall retaining wall, concrete retaining wall, thicker bottom part of the retaining wall, and the last one, the curved shape of the retaining wall. So that means you repeat all the characteristic from the table. You choose one. There's a L, high, concrete, and thick curve. Then we finish. So this one we call table form answer for the AC. Okay, so hopefully you understand how to answer the AC question. Okay, this one is a one type. This one is a section C. Okay, we still got section B, the AC question. Okay, the section B AC question, they don't have anything like you to choose. They want you to exactly to explain by yourself. There's an open one. Open by yourself to create the characteristic. Okay, this one is a closed one. Closed one means that got table. They let you to pick which one you want to choose. Okay. Oh, now we finish already because the time also time's up. Okay, the next lesson sure is 2.3 lah, the gas pressure. Okay, gas pressure just now is a liquid, is it? So 2.3 is just talking about the gas pressure. So the gas pressure must be including the atmospheric pressure. So hopefully the student today I discuss all the exercise you can mark by yourself. Okay, if you do, then you mark it. Okay, then put inside the file. If you don't have the file, then you keep first because I know you return back to you. Okay, so the student you still not yet subscribe me, please subscribe my channel. Okay, so hopefully you understand, hopefully you enjoy my lesson. Okay, so just thank you for everybody for the watching and also respond me for today lesson. Okay, so thank you everyone. Thank you Yiru, thank you Sabrina to answer my question just now, and Ling Hannah. Okay, Jessica also got. After that we got Shafika and Siti. Siti don't know go where he suddenly disappear. Okay, so just thank you for you all for your watching today to answer my question also. Okay, so any question that means you can PM me and request the question how to do or anything you not understand, that means you can recall back. Okay, so anybody, the student respond? Okay, bye. Okay, can see me or not? Bye, ah. Then we finish everything already. So the student, one more thing, forget to tell the student. Yeah, the student asked me already today the code. Okay, today code for your Google form. Today we got one of the code. Okay, Yiru, you help me to type. That's a depth. 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 Okay, water depth, the depth. Capital letter. Depth. After that, underscore. Find S2. Find S2 capital letter. Underscore 2021. Okay. Hopefully I can type. So you also help me to type capital letter for that. No hashtag. TEPTH. Okay. Then you put underscore. Then you put five S2. 5S2, that means the file size 2. Then again for the underscore. Again for the underscore 2021. Okay. So I type ready. So I repeat also. Hopefully you can see that. Okay, can you see the word that? DEPTH. Okay, underscore file size 2 underscore 2021. Okay, don't copy paste. You go there and type by yourself. Okay, in the Google form. Okay, for today attendance. Okay, understand? So, student, okay, got any response? You can see or not? Okay, so our lesson just until here lah. Okay, bye. Everybody busy already, busy to type. Okay, so if nothing, okay, bye. We finish already. So hopefully you understand how the liquid pressure. Then we go another one should be the gas pressure. Okay, bye bye. Bye bye for everyone, student. Okay, thank you. Thank you, Sabrina. Okay, then we just finish.